What if I told you there's a new kind of computer technology that could completely transform our world? A technology so advanced some call it magical. I'm talking about quantum computing. Imagine you wake up one morning and turn on the news. The headlines blast about how a new quantum computer created by NASA has experienced something unprecedented, so mind-bending that they had to shut it down. What happened behind those closed doors? What secrets were discovered? The mysteries of that shutdown haunt you as you go through your day. This new quantum technology sounds almost supernatural, bending the laws of reality itself. Your curiosity peaks. How can we tap into the power of these exotic machines? What will it mean for the future of technology, security, even the search for alien life? You dive deeper, learning how quantum computers leverage the bizarre qualities of subatomic particles to perform calculations beyond any traditional computer, about how tech giants like Google and IBM now race to build larger quantum systems, promising to one day revolutionize fields like medicine, AI, cryptography, and more. But with all new technology comes new challenges. You discover the coming quantum apocalypse, how these computers could crack all modern encryption, threatening privacy and security across the digital world. Diving deeper into the cosmic conflict, you uncover encryption's last stand, the global mission to re-architect the very foundations of online security. Emerging from an afternoon down the quantum rabbit hole, your mind still spins. What will the quantum future hold? Will we harness its power to cure disease and expand human knowledge? Or will it lead us into an era of unprecedented threats to security, privacy, and democracy itself? One thing is clear: quantum is a revolution centuries in the making. So strap in and welcome to the quantum age. Our journey begins with a question: how did we get here? To understand quantum, we must go back over 100 years. We journey back to the early 20th century, when the foundations for this quantum revolution were laid. It started with Max Planck's radical idea that energy comes in discrete chunks called quanta. This contradicted classical physics and shocked the science world. Hot on his heels was Werner Heisenberg, who in 1925 introduced his now legendary uncertainty principle. This pillar of quantum mechanics revealed an intrinsic randomness at the subatomic scale, where particles behave in strange, probabilistic ways. In the decades that followed, scientists like Einstein, Bohr, and Schrödinger would engage in fierce debate. Their clashes and exchange of ideas mapped the exotic realities of existence below the micro. But it wasn't until the 1980s when physicist Paul Benioff first envisioned something shocking. What if we built a computer that leveraged the bizarre quantum realm, a machine performing calculations based not on classical bits, but these mysterious quantum entities? In that moment, a technological revolution was conceived. Scientists dreamed up quantum versions of computers, sensors, and communication networks. Each promising mammoth leaps over our silicon status quo, but fantasy was still a far cry from reality. They needed to domesticate the untamed world of subatomic particles. Cut to the mid-1990s when mathematician Peter Shor birthed the killer app of quantum computing, an algorithm for prime factorization exponentially faster than anything achievable by traditional means. Suddenly, these exotic contraptions had found demonstrable real-world value. They could crack secret codes and upend encryption security. Quantum was now a strategic priority. The global race to transform fantasy to reality was on. In the decades since, we've achieved many quantum firsts: entangled photon teleportation, multi-qubit systems, and increasing computational power. With every discovery, we inch toward the coveted goal, quantum supremacy, when exotic machines surpass all traditional means. Some believe this milestone has recently been met in secret by Chinese researchers, indicating quantum's coming of age. Today, tech titans Google, IBM, and Microsoft pour billions into the quantum gold rush. Their dream: to one day commercialize this lab tech as the next must-have gadget. But will encrypted data stand resilient as these exotic machines continue their relentless march? Only time will tell in this brewing conflict between quantum might versus encryption's last stand. Our quantum journey now brings us to the present day, an era of historic opportunity and uncertainty. With quantum research accelerating, exotic prototype machines are already demonstrating an ability to crunch data and defeat encryption protocols once thought unbreakable. Many fear the coming quantum apocalypse, a future period when our data fortresses constructed in a classical era now face compromise from these emerging computational titans wielding unimaginable power. No sector may be spared. Finance, government, healthcare, and more are exposed as quantum takes its throne. Trillions of dollars and society's digital fabric hang in the balance. In response, governments rally their cyber armies to the coming storm. In the US, the Department of Energy and National Institute of Standards and Technology marshal resources toward a post-quantum future, one where new encryption algorithms, protocols, and computational models maintain secrets even in era of the quantum king. But is it too little too late? Will the quantum offensive outpace our ability to defend, leaving cinder in wake? The encryption debate becomes more philosophical. Is achieving true data privacy in a quantum future even possible? Is the quest to safeguard all personal and commercial secrets destined for failure? Futility against exponentially growing quantum might? These questions divide thought leaders. Cyber optimists bet on human ingenuity that will rise to the quantum occasion with innovation in science and policy. Cyber pessimists see a more gloomy horizon, wide-scale compromise of society's digital fabric as quantum computational supremacy leaves all past security models in ruin. Whichever camp one subscribes, uncertainty rules the day. The quantum drive unleashes existential questions on the true nature of privacy in an era of unfathomable processing power. These debates rage in the halls of academia and business, but quantum ripples also stir the societal pool. What are the cultural effects of technologies enabling new kinds of creativity, discovery, and connectedness? How will artistic expression evolve? What happens to the nature of human relationships when exponential computational growth allows lifelike synthetic realities and rapid information exchange over great distances? The quantum timeline is debated but inevitable, and with it, we charge forward to civilizational unknowns. Our quantum odyssey culminates with the grandest question of all: are we alone? SETI researchers propose expanded use of quantum techniques, like computation, sensing and communication may aid the search for extraterrestrial intelligence. Perhaps we'll hear their quantized signals, or discover advanced alien civilizations exploiting quantum phenomena beyond known natural limits, activity that may reveal their existence. Which brings our quantum thought experiment full circle. Did NASA's shutdown of their quantum computer reveal contact? While a stretch for even the most adventurous Hollywood science fiction, the point highlights quantum computing's unlimited sci-fi fuel. Realities hardly fathomable may await in the shadows of the quantum realm. The secrets that quantum systems unveil may outpace ethical safeguards and legal policies. Classically encrypted data and computation face compromise by these emerging exotic machines, and quantum fuels an explosion of sci-fi potential, with good and ill effects to civilization. The only surety is epochal change is upon us. The quantum future arrives. Are we ready? With that said, thanks for watching, and until next time,